So just a reminder, we actually took the pump and we mushed the air into here. And when we mushed the air into there, we saw no change in volume, but we did see an increase in the pressure. We might have seen an increase in the temperature because when you pump things, things get pretty hot. So basically the thing got heavier because there was more air inside the bottle because we pumped air in there. So this is known as the Cartesian diver, and in the Cartesian diver we applied pressure to the outside here, so the pressure increased, and when the pressure increased, the volume of the bottle actually decreased. It got smaller, so we're changing temperature, pressure, and volume. And then, once we did that, the air inside the pipette compressed, and when that air inside the pipette compressed, the pipette got heavier and it sank. And if you look really carefully, you can see the air inside there actually being mushed. Now, I know that's a technical term, but this thing is based on something called Boyle's Law, which is volume and pressure. So you should mention these things. In the balloon bottle, what we did was we put hot water in here, and then we put this thing going over there, and we put it in the window where it got cold. So we were clearly dealing with temperature. When it got cold, what happened is the air molecules moved more slowly, and when the air molecules move more slowly, the pressure went down, the volume went down, and the balloon got sucked into the bottle. Sorry about writing all over the screen, but you guys should be able to see that, and hopefully you should be able to figure this out. Great. So this is a pretty cool one. We put the water in there, and when we put the water in there, we got that card that was kind of wet over there, and then we turned it upside down. And normally you would expect this thing to kind of basically dump out, but what happened is that there's air pressure down over here, and that air pressure is pushing up on the card, and the pressure pushing down from the water is equal to the pressure pushing up from the air, and the thing didn't leak. So in this one, basically, we didn't manipulate much. We didn't change temperature. We didn't change volume. We did not have a chemical reaction. And so this is just air pressure pushing up, and the air pressure pushing up held the water inside the Dixie cup, which actually I think is pretty cool. So this is cool. Make sure you mention that when you do your slide for me. So in this one, it was a chemical rocket, and so we took Alka-Seltzer, and the Alka-Seltzer changed from a solid to a gas. So this did have a chemical reaction, yeah. And so when that chemical reaction occurred, we released carbon dioxide. The carbon dioxide increased the pressure inside the flask. The volume inside the flask increased as well. When the flask actually exploded, the rocket launched, as we can see over here, and it went up. So we had a chemical reaction, we increased pressure, we increased the volume, and we saw this thing head out into hyperspace. You guys know what hyperspace is, right? So the last one was the suction cups, and in the suction cups, basically we had those two suction cups, and air pressure was pushing hard on the two suction cups, and you had a pretty big surface area there, and you were not able to pull those things apart. And the reason is that air pressure was really, really high, and the high air pressure basically kept these suction cups closed and prevented you from pulling these two things apart. And that concludes this. Add one more slide for me with your picture. Upload this to YouTube and email me a link. Great. Thanks very much. See you on Thursday.